In the last video, we went in depth. That is, we discussed in depth the meaning of having a positive slope and a negative slope, and that is the meaning in the graph of the derivative of that function. So here we're going to use what we've learned to actually just sketch the first derivative and the second derivative on the blank axes on your own paper. So let's label this. This is the graph of y equals f of x. And let's start by exploring where this graph has a horizontal tangent line. So if this green line is a roller coaster frame and you're writing it, at this peak, your roller coaster car will flatten out. It will also flatten out here, here, and here. So at all those flat spots, the line tangent to y equals f of x must have a slope of 0. So those are the easiest spots to mark first. So what I would do is I would get a ruler and I would line it up, and then I would mark each spot on this axis. Okay, as you can see here, I went ahead and labeled these 4 points on this blank axis, and they correspond to these 4 points on the axis above. And those are the 4 places where the graph of y equals f of x has a horizontal tangent line. So along these 4 marks, I'm going to mark 4 spots. So these are the x-intercepts of y equals f prime of x. Now we're going to estimate how positive and how negative we think the slope is. Let's start with the positive slope intervals. So as you can see, on the left, we are traveling uphill. Then we're traveling downhill. So I'm going to ignore this interval. So we're traveling uphill on this interval, this stretch here. We're also traveling uphill on this stretch, and we're traveling uphill here. So that means that along the x-axis on these intervals, our graph of the first derivative should lie above the x-axis. Now it suffices to figure out how positive these lines should be. This looks pretty steep to me. In fact, this looks pretty close to some very large numbers, almost close to a vertical line. So I'm going to ensure my graph of the first derivative comes down fairly steep. And then on this rightmost interval, again, it starts off fairly close to 0. So I know I'm definitely going to get close to 0 here. But then it gets steep pretty quickly. So again, I'm going to sketch this graph so it's going uphill at a pretty quick pace, or very steeply. And then between this flat spot and this flat spot, we have more of a gentle slope. So the tangent line here starts off fairly flat, then gets steeper until it starts to flatten out again. So that means we should start off fairly close to 0, go up, and then flatten out. Now we need to fill in these 2 intervals here. And looking at the graph right above, it's clear that this slope is downhill, so negative. So the graph of the first derivative should lie completely below the x-axis on those 2 intervals. Furthermore, getting a ruler out, go ahead and get a ruler or your pencil and trace out these tangent lines. Maybe get 2 and see if you can tell which one of these is more negative than the other. Now that was kind of a trick question because these sketches should make it clear that the slope here is almost about the same as the slope here. So I'm going to have these 2 slopes, these 2 valleys on this curve come down to about the same place since they both have the same negative slope. And more concretely, the slope here is what I'm looking at. So this slope kind of here and here, so at these points they should be about the same. Alright, so I went ahead and cleaned up my graph of the first derivative. So this is an estimate of what the graph of the first derivative looks like compared to the original graph of the function. Yours should look fairly close to mine. You might have chosen to go up a little higher here, but as long as you have these spots both negative on these intervals and you're positive, that is, your graph lies above the x-axis on these 3 intervals, and again negative, so it lies below the x-axis on these intervals, then you're good. Okay, so now let's continue and let's sketch a graph of the second derivative of this function. Okay, so on your screen you should just see the blank axes and the graph of the first derivative, and here I'm going to sketch the graph of the second derivative of this function. And again, it's always a good idea to start with the peaks and the valleys, because on these spots you know that your tangent line will be horizontal. So again, we're exploring the line tangent to the first derivative, and it will be 0 about these 3 places. So go ahead and mark on the graph below it these 3 spots. Okay, so I've marked off the 3 spots where I think the second derivative will have an x-intercept because the slope of the first derivative is 0. And now it suffices to figure out what is going on, because these 3 intercepts break up our line into 1, 2, 3, 4 intervals. So on this first interval, what is the graph of the first derivative doing? Well, it's traveling downhill. So all these tangent lines are negative. So on this first interval, the graph of f double prime should be below the x-axis. Additionally, this line is very steep here. So we need to ensure that that is reflected on the graph of the second derivative below. Okay, so there's that first interval. Now on this second interval, what is going on? Now on this second interval here, which corresponds to this interval here between these 2 peaks, so that's here. Now on this second interval, which corresponds to this section here between this valley and this peak, what is going on? Well, from here to here, our slope is positive again. So you notice it starts at 0, then as the tangent line continues, it gets more and more positive, and then it's flattening out again to 0, so it comes to this intercept. So let's go ahead and sketch out a graph that lies above the x-axis to represent the positive slope from here to here. All right, there it is. So now on this interval, from this peak to this peak, what is going on? Well, from this peak to this valley, our slope is negative again, so the graph of the second derivative should lie below the x-axis. And then finally, from this valley here on, so on this interval, this graph starts off to have a tangent line that is 0 and then gets a little bit positive and then gets more and more positive. So it's getting steeper as you go. Let's go ahead and sketch that. And there is the estimate of what the second derivative would look like. I hope this video was helpful.